Hello everybody, and welcome to this video on Module 9, Advanced Probability. So before this lesson, we've been talking about our basic probability, what is the chances or likelihood of an event to occur. And our examples remained fairly simple. Now what we're going to get into is some more advanced probability, where we're finding probabilities of compounded events using the additive rule, which we're going to talk about, and then also for sequential events, looking at using a multiplication rule, I like to think of. Okay, so let's get started with our first formula or rule, which is our additive rule. So when two events, we'll call them A and B, are mutually exclusive, the probability that A or B will occur is the sum of the probability of each event. And this is called the additive rule. So this formula here is what we're going to use and practice with for a bit. So what I'd like to highlight with this rule is notice the word or. So we're looking at mutually exclusive events. So things that are not, there's no overlap. It's either this or this. So if we think back to our Venn diagrams where we left off at, so in this situation, we'd have event A and event B, but there would be no overlap because they are mutually exclusive. Okay, so let's do practice. Now we've already been working with this data. We were working with it in the earlier module where it was the Canadian Blood Services. And we know that 46% of Canadians have O, 42% have A, and 9% have B. And then we also did the work previously to find out how many have type AB. So if we look at this question, down here it says, someone volunteers to give blood. What is the probability that this donor has type A or type B? So notice the word or here. And we're going to use proper notation for our probability. So we're going to look at what is the probability that this volunteer has type A or type B. So this is where we use this additive rule. So we're going to first add up the probability of, determine the probability of type A, and then we are going to add it to the probability of type B, and that's because it's A or B. And when we pull up our probability for type A, again, either from our previous notes or from the information above, we know that that's 0.4200. Again, we round our probabilities to 4 decimal places. Our probability that a volunteer has type B, we found that to be 0.0900. So when we add those up together, we get a probability of 0.5100. And that is our final answer for this particular first example. And that's using the additive rule. So when we move on to our next step, which is repeated trials, independence and multiplication rule, this is sort of the opposite rule, or not opposite, it's just a different rule than the additive rule. So let's move up here, and it says sometimes we want to know the probability associated with a repeated trial, 2 or more events that occur in sequence. So this, and then this, and so on. So assuming these events are independent of each other, the outcome of the first event does not affect the probability of the second event. Then we can use the multiplication rule. So the probability of 2 independent events occurring in repeated trials is the product of the probabilities of the event. So here is our next important formula. So notice the difference between this one and the additive just above. Here we have the probability of A and B happening, and that means it's equal to the probability of A times the probability of B. So for this one, what I want to highlight is the word and. And the word or and are really helpful when we're determining which rule that we're going to apply. So let's go ahead and practice using this new multiplication rule. It says, events A and B are said to be independent if the outcome of the first has no effect on the outcome of the second. So one event and then the next. Using the data or information from above, from the Canadian Blood Services, among 4, keyword here 4, potential donors, what is the probability that all of them are type O? So we have 4 volunteers that we have to consider. So our notation here is the probability that 4 are type O. So it's not just one person, it's 4. So because it's 4 people, it's like the first person is type O and the second and the third and the fourth. So notice I'm exaggerating the word and to help understand why we use the multiplication rule here. So what it's going to mean is that we're going to take each probability and multiply it by itself. Now, it's the same probability for all the volunteers. The first one is going to be type O. We know that probability is 0.4600. The second person, type O, so same probability. Third person, type O, same probability. And last person, the fourth person, type O, same probability. So when we multiply all those by each other, we're going to get a new value that we're going to round to 4 decimal places. You can write it out as I have, or you can simplify that by just writing it as 0.4600 all to the exponent of 4, right? Because we're multiplying it by itself 4 times. And what we end up getting as a final answer, again, rounded to 4 decimal places, should be 0.0448. So notice how this probability is getting closer and closer to 0 because it's more and more unlikely that every person is going to be type O, right? So the chances of that happening become less and less, which means our probability goes down. Okay. Next part here, part B, it says all are type A. Okay, so again, using the same idea as we did for part A, this time, just as a side note, we know that the probability that someone has type A, we know it's 0.4200. Okay, so just that as a side note. I guess I should have written that up here. Probability that somebody is type O, we know to be 0.466. Okay, just to sort of pull that information from above. Okay, so if all of these volunteers are going to be type A, we're going to set this up exactly the same, except I'm going to say probability that 4 are type A. And I'm going to use the shortcut, which I'll highlight here because I feel like that's a lot less work, especially when we've got multiple volunteers that we're looking at. So I'm going to write this as, let's see, it's going to be 0.4200 all to the power of 4 because there's 4 of them, which gives me a probability of 0.0311 as my final probability. So again, notice how all my probabilities, I'm rounding those to 4 decimal places. I want you to practice that. That's what we're going to be using as we move through this course. All right, carrying on.